Hello and welcome. Here we are with some stuff. We have a triangle. I'll get rid of the cam in a second and we'll get into the real code. But basically the goal of this lesson, this session, is to add some sort of first-person camera. I'm going to do that in a few stages. First of all, if you look at this source code, a lot of this is being handled, most of it, including the update code, is being handled by the renderer class, and that's a little bit, we can do a little better than that. So the first stage is we'll take this code, break it apart into basically the classic model view controller triple, and then we will start detecting events and printing some debug info out on the screen, check that we're detecting mouse movement and keyboard presses and everything, and then we'll go into the code of updating and controlling the camera. Okay, so let's get into it. Okay, so to start with, like I said, we're going to refactor this, break this down into a bunch of subclasses. So we'll just go to the source folder, create a new folder, and that will be where we'll store all of our model classes. Now I'm going to take this from the bottom up. So we're going to have a scene, and then a scene will have a bunch of other classes, but I'm going to make those bottom subclasses first. Starting with, I'll make a file in here, which I'm just going to call math stuff. And the reason for that is I'm going to do some trig, but I noticed that the math library doesn't seem to have a conversion function, so let's make one. We'll just go make a function. This is just for converting between degrees and radians. And it'll be very straightforward. We'll just do the conversion. And having that function there will make the other code a little bit cleaner. So we've got that. That's nice. Maybe we'll add some other functions to that in future. But for now, we'll just go back and we'll add a new file. It's going to be a triangle and a camera. So let's start with the triangle. That's a little more straightforward. And I'm going to need a few things. I'm going to need, oh, that's weird. I'm going to need a three-dimensional vector to get the camera's position, the triangle's position and things, and a four-dimensional, doesn't recognize. A four-dimensional matrix to store the model transform for the triangle. Okay, fair enough. And then we'll go ahead and import our conversion function. There, we've got that too. Okay, so go ahead and define the class. As well as its class variables. I mean, this should be pretty self-explanatory. We'll have the constructor where we take in the information. Okay, yep. So we're only going to give it one angle. That's the rotation around the z-axis, which is what we are setting on line 13 over here. So as you can see, we've got a triangle here which is already spinning, but that is happening in the renderer class. If we go to the renderer class, as part of its render function, it is, where are we? Incrementing the angle over here and appropriately setting the model. So that's why this is always turning around. It requests an animation frame each time, which keeps it on an infinite loop. So what I want to do is I want to make an update function which does the same thing as the triangle is doing right now. There we go. So we just keep incrementing the angle, spinning around. Now the next stage is we need to create the model transform. So we'll go, okay, take the model. We'll start by creating a new mat4, and then we'll go ahead and translate. So for whatever reason, the IntelliSense just isn't working at the moment, which is annoying. So I'll just step through the arguments. So as with all of these GL matrix functions, turns out they do return the final value, but you can also do them in place. So this first argument, this matrix will be populated with the result matrix. And then the next argument is the original matrix that we want to work on. And then the translation vector that we want to apply. So basically, we take the model matrix in, we apply this translation, and then the result is stored back into that same matrix. Then, okay, so we send it to a position, and then we rotate it. And this is just one of those things. This actually really bothers me that the order of transformations goes this way, because logically we should be rotating first and then translating. But I've done this, and it has to be this way, otherwise it does the opposite thing. It really bothers me, and the same thing actually happens in GLM, in OpenGL. So whatever it is, what it is. Okay, so what do we want to do? We want to rotate around the z-axis. The last argument here is going to be the angle, and that has to be in radians. As you can see here, I'm doing this in degrees, so I'll have to convert that. Just pass in, yeah, the rotation and convert that to radians, and yeah, there we have it. Okay, so finally, this last part is optional, but I just liked to put it in. I'll have a function which queries the model matrix. And it's nothing too exciting. It just returns that matrix. Okay, so I'm actually going to grab all of this code because the code for the camera class is going to be pretty similar. So just pop in here, make a new file, camera, and then let's have a look at it. Let's jump into it. So yep, again, we're going to use all of these imports. That's fine. The class will be called, oh geez, camera. Yeah, we'll have position, we'll have Eulers, but instead of model, we'll call that view. And then we'll have the three fundamental vectors of the camera, which is the forwards, the right, and the up. Okay, so when we create this, we're going to have three arguments. Theta will be the rotation in the horizontal plane, northeast, southwest, and phi will be the rotation altitude-wise, so up and down. And perhaps we could have done this originally with the triangle, but I'll just set this here. So another way to create a vec3 is with just an array list just like this. Now, something a little subtle is I need to give these starting values, even though we're just going to overwrite them. But the issue is, if we were, okay, so here is the update code from the triangle. The first step here was we created a blank model matrix and then we populated it. If we didn't do that, then it would complain that this dot model is undefined, which, fair enough, it is undefined. So that's what we're doing here, and there's no reason to do it one way or the other. I just wanted to do that. All right, so how will the camera update? Well, essentially, it's going to set all of its vectors. So we're going to calculate or recalculate the forwards, up, and right vectors. Now, to get the forwards vector, we're going to use spherical coordinates. And this is one of those things, I feel like I've gone through it a whole bunch of times, but repetition is always good. So if we were going completely, in the horizontal, we'd get the second, position 2 of our Eulers, which is the rotation around the z-axis, and cosine of that would be the x component. Sine of that would be the y component, and then 0 would be the z component of the forwards direction. That's if we're just looking in the horizontal. Now, if we're looking in full 3D, so up and down as well, as we look up, the horizontal component of the forwards vector shrinks, going down to 0. Now, I actually use a modified version of Eulers where 0 is horizontal. If we looked at it as the rotation away from the z-axis, then actually an Euler of 0 in the 1 position would be looking up directly at the z-axis, but that doesn't feel intuitive to me, so I'm going to do it this way. So think about it. Let's say we have a phi of 0 degrees. Well, cos of 0 is 1, so that maximizes the horizontal components of the looking. Let me just bring this over, actually, make it a little bigger. Okay. And then if we had, took sine of that angle, well, when we're at 0, sine of 0 is 0, so we've still got no vertical component. But then as this angle approaches 90 degrees, cosine of 90 is 0, so we've got nothing in the horizontal, and sine of 90 is 1. Anyway, I'm sure everyone's getting pretty frustrated because we already know spherical coordinates, but if you don't, look it up. Anyway, so there we have it. Now we need to calculate the right vector. So we're going to, what am I doing? Go into the vec3 library, perform the cross operation, cross product, store the result in our right vector. Okay, now if we take the forwards direction, cross with the completely up in the z direction, so we go this, forwards, cross with 0, 0, 1. This is a fun exercise. Have a go at this. Take your right hand, take your fingers pointing towards you because that's the forwards vector, and then curl them up because that's towards the up vector, 1 in the z. Your thumb points to the right, and so that is how we can verify that this is correctly calculating the right vector of the camera. And then we'll go ahead and do this again. So we'll take, let's see, take the, I'm going to store this in the, in the up vector. Let's have a think about this. Take your right hand, point your thumb up, and what are your fingers doing? First, they're pointing towards you, and then, wait a second, let me just think about that. Okay, so they could go towards you, then to the left. We don't have a left vector. Let's do it the other way. Point your fingers to your right, and then towards you. Curl that around, so that it's going right, and then forwards. Okay. So this is calculating the 3 fundamental directions, forwards, right, and up. All good. Okay. So now we need to calculate the camera's view matrix, the camera's look at matrix. And to do this, we need a few things. First of all, we need to know what our target is. In other words, what we are looking at. So to do this, we'll go ahead and create a blank vec3, and then we'll populate it. So we'll go vec3 add, store that result in target, and we will add, if I can spell, position plus our forwards direction. Yeah, that's literally the point that we're looking at. So now we can go ahead and finally create the view. Then we'll go, mat4, create lookat. We'll store it in the view. So we have where we're looking from, that's our position. Where we are looking at, that's the target vector that we calculated, and what our up direction is. We've calculated that, as well. So there we have it. Okay, so then down here, instead of get model, we'll just make this get view, and we'll return our view matrix. And there we have it. Okay, so we've made a triangle, we've made a camera. Let's bring them together in a scene class. So we'll just go to our model, go create new file. I keep wanting to write .py. I've been doing too much Python. Is there such a thing as too much Python? I don't know. Okay, so let's import all of those classes that we just made. And now we can define our scene. Okay, let's go ahead. I'll just make the getters. Pretty straightforward. Again, not strictly necessary, but there's just something about that I think is nice, so I'm keeping it in. All right, so we need two things, update and the constructor. Let's make the constructor first. Okay, so it's super important to initialize the triangles to an empty array. Otherwise, if we leave line 11 out here and then we just push a triangle on, then TypeScript's going to complain. The console's going to complain. It's going to say, hey, this is undefined. You can't push something onto something. What am I saying? You can't push it on when it's undefined, the array. So we need that. But yeah, so we're creating a triangle at an x coordinate of 2, 0, 0 for everything else, rotation of 0, and then we'll make a player. And we want the player to be a little bit away from the triangle, so we'll put it on -2 on the x, and give the player a little bit of height. But otherwise, yeah, we'll keep all these other directions at 0. Okay, very cool. All right, so now the update. Okay, so this is another one of those parts where people are going to get frustrated because I'm coming into this JavaScript, TypeScript thing from very little background. So all of this stuff is sort of novel to me. So we have for each, and then for each operates on a collection of some sort, and the argument it takes is a function, an anonymous inline function, which it populates. This triangle is a temporary variable looping through the set, and what we do is we call each triangle's update function. I probably don't, yeah, we don't need that. So there we have it. So that will, you know, at the moment we've got one triangle, but this will do all of them. And then we say, okay, also update the player. Cool. So yeah, very nice, very nice. Now I'm going to work on the renderer, so we can close this down. That's all fine. Go to the source folder. Again, make a new folder called view. And let's see, what's going to, oh no, not there. Not there. There we go. Okay, so I'll move everything. That's so loud. Okay. Yeah, don't ask me. I want to do it. Come on. Okay, so everything which could be associated with rendering. So you could argue that a mesh and a material technically are more like model data, but I'm just going to put them here. That's fine. There we go. And we'll put the renderer there. Okay. I've double checked it. I'm happy with that. So onto the renderer class. Now the issue is that this is sort of coupled. The renderer is doing things that it should not have to worry about. For instance, yeah, see, a little dodgy, totally dodgy. We're not going to do this. So this T parameter will completely get rid of it. That is fine. And this initialize function will not render. It will just create things. We'll go, oops. Well, that's not working properly. That's really not working properly. Oh well, that's fine. Okay, so set up a device. That's a thing. Make pipeline. Yep, create assets. That's fine. Okay, so over here, where we're rendering, let's not do that. And I'm actually going to set this up just the same way everything else is happening. So this will be an asynchronous function. Reason for that is that, well, this graphics API throws work over to the graphics card, which works a little bit out of step with the normal flow of the program. Now, with this render function, I want to take some arguments. And in order to do that, I need to know about the classes that I have. So I'll just import these. Okay, so we step one directory back. So from view, we step back to source, and then from source, we step into model, and then grab camera. And we'll do the same thing with the triangle. Okay, and then we'll just go down and we can use those. So in the render function, I'm saying, okay, well, we're going to render, but we're going to have a camera object. And we're going to have a list of triangle objects. Okay, now I'm just going to get rid of these comments. That's fine. So I'm going to move this down. Actually, change my mind. I'm happy with that, but I am going to have to move this stuff down. So, of course, for the view, we don't need that. We need to get the camera's view. So take the camera instance and call get view on it. Now we could argue, why are we not simply calling that here? Why is that a separate thing? And the reason is it's common to actually pre-multiply these matrices and get a single model view projection MVP matrix sent in one go, because if we know exactly what the multiplication is, why are we doing it for every vertex? But this is a simple case. We only have 3 vertices, so that is fine. All right, so just double checking. Yep. Okay, so I'm just going to go down to maybe this part here. Okay, so this is the work that we're doing on each triangle. So of course the model matrix is something which is varying with each triangle, so we'll grab that and work with it. Okay, so we'll say, okay, take the triangle, get its model transform, and then we can go ahead and write that in. So we'll go right back up above, here where we are writing the model transform. So as you can see, this is a little bit funky, but it sort of works. What we're doing is, first of all, we write the view and projection at these various offsets, and then finally, when we get the model, then we write that in. But yeah, otherwise the same. Now we then set the bind group. Remember that the uniform buffer is associated with this bind group over here. So essentially, this is setting the data which will be used for rendering. Now you may notice, hey, we've only got one triangle. Wouldn't it be great if we could draw a whole bunch of them, which is a bit weird, right? Because we're doing a loop here. It turns out that WebGPU does not have an equivalent to push constants. In Vulkan, you can set an amount of dynamic data, usually about one matrix. WebGPU doesn't have that. Or in Metal, you can set vertex bytes, set fragment bytes. Again, WebGPU doesn't have that. Might be coming in a future installment. But this will probably be the next video in the series where I write to a whole buffer with all of the model matrices and then go ahead and render things in one go. But for now, this will only handle one triangle, just one step at a time. So we have this. That should be fine. Of course, we won't request an animation frame because that's not how this function is being used anymore. But yeah, provided I haven't made any major errors, that should be working fine. So we'll now take another step back. So I don't understand why this initialize function is closing everything. That has to be an error. Oh well. So over here, we'll go ahead, we'll add another folder, call this control, and here we'll have another file called app. Okay, so we're almost there. What we'll need to do is grab the renderer and scene classes. Yeah, so there we have it. The app is going to need to store a reference to the canvas because it sort of needs the canvas to get mouse motion events and things, to get input. It's going to have, yeah, a reference to the renderer and the scene, which will manage all of the objects. So this is a little strange. I'm going to break this into a few steps. First of all, we'll have a constructor, and the constructor will take a canvas as its argument and set things up. Then we'll have an initialize function. If you remember from the main, the renderer's initialize is asynchronous, so it has to be done separately to the constructor because the constructor cannot be asynchronous. It's just the way it is. So let's start with the constructor. Okay, cool. So we just construct everything. It is what it looks like. Then we'll have the initialize function. And really all that does is initializes the renderer. But I have to wait for that because I don't want the renderer to be ready before the main loop starts. And then finally, we'll have run. Now, just like the renderer, the render function was an anonymous function, same with run. I'm just future-proofing here. I might want to set it up so that when I hit a certain key, the game stops running or the renderer stops updating. But yeah, so what are we going to do in the main loop? Well, of course, we will update our scene and then render it. Okay, cool. So that is our app. Pretty straightforward, hopefully. We'll now just go to the main and we can really simplify this. Okay, yep, so we go ahead, we make an app, and then we initialize the app, and then we run it. Okay, so that's all of the code for this bit. Fingers crossed. Let's see if we've missed anything. We'll just go make a new terminal and start that process. Go ahead, build and serve everything. Ooh, that's not good. Okay, what have we done? What have I done? Okay, look at needs a capital. Okay. Again, I wish IntelliSense was working. Right. Okay, this should just be Eulers, not Eulers 2. Okay, fair enough. Okay, then scene line 14. Yes, that should be a comma, not a semicolon. And 16's probably been thrown off by the comma. 17 again, probably the comma. Let's try that again. Okay, that looks fine. We can just go over, refresh that. Ah, cool, it's working. So as you can see, the triangle's there and it's more or less in line with the camera. This indicates that, yeah, it's working. Now, I did notice something. I'll see if this happens again. If I go Control-Shift-I to open up the inspector and I go to the console, I seem to be getting about, 4 or 5 errors, which are very strange. It's saying that the queue and all of this is undefined, is not of type GPU buffer, where it clearly is. But the weird thing is that it's only 4 or 5 errors and then it seems to work. So I'm not entirely sure what issue is happening there. I've had a look at it. It doesn't seem to break the program, but it is annoying. So if anyone has any ideas, let me know. I don't know. It's weird. But yeah, there we have it. We've got our model view controller working. This is I would call this a better engineered, I would call this a better engineered system. Let's have a look at bringing in input. Okay, so to check that our input events are working properly, I'm going to add some debug information to our page. We'll go to index.html and I'll just paste this in. So here we are just underneath our canvas. I'll bring this in, have a bunch of labels. So we have this key label, empty section, mouse X label, and so on. And here we're going to display some information. Now, in order to work with events, there are ways we can do it in regular JavaScript. However, from what I've heard, these methods, if we just use regular JavaScript, the key codes can be a little different depending on the underlying system. And it's a little cleaner to use jQuery for those. So no problem, just open up a new terminal and we'll go npm install jQuery. Fair enough. And then we'll say, okay, npm install save dev, and then we have this at types/jQuery. So install jQuery will give us the underlying jQuery library, and this types jQuery will give us the TypeScript definitions that we need to use jQuery within TypeScript. Okay, so then we can go to our app. There we have it. And I'm just going to give myself some extra variables. Gonna have a bunch of labels, so I'll have a key label. And a mouse X and Y. Okay, let's just start with the key label. So we'll go to the constructor and we'll set this up. We'll say, okay, grab the key label. There we go. Okay, and then I'm going to define an event to call when a key is pressed. So I'll just call this handle key press. Now this has to take an argument, call that event, and that type is a jQuery key press event. Okay, so what I'll do is we'll grab our key label, set the inner text, and I'll set that to the events code. There are many things we can read. I'm going to read the event code. So what I then want to do is I want to set up the document so that when the key event, when a key is pressed, that is registered. So using the jQuery syntax, which I'm not above saying, I looked this up. I'm a graphics programmer, not a web developer. Go key press event. And we could just send in this handle key press. However, that doesn't really know what this is, if that makes sense. So instead we can pre-bake that with an anonymous function. So it's the fact that we're calling this .handle key press that then this keyword is defined inside this function. If that makes sense. Maybe that was super basic, I don't know. Okay, so that is registered. We can go ahead and test that. So we'll just go set that up. Uh-oh. What is wrong with this? I think I see here. Okay, let's see if this works. So we'll just go, in order to use jQuery functions, we'll import that $. Okay, that seems fine. Let's refresh that, see how that's working. Okay, so as you can see, we have all of this. Now if I click onto the document and then press a key, it is working. So these are the key codes that we can query when we test things. For some reason, it doesn't work with arrow keys. That doesn't make sense, but hey, who am I to say? So let's keep going here. So on that vein, we'll go ahead and grab the mouse labels. And then we'll register a mouse move event. So this is mouse move. And then I'll make a handle mouse move function in a second. Yeah, there we have it. Okay, so here we have, that's our handle mouse move. We're going to set the X and Y labels. What we want to do is we want to go event screen X. Again, if I had IntelliSense, this would be popping up with all the suggestions. It's not working, annoying. But yeah, convert that to a string because that is a number. We'll set that, and then we'll do the same thing with the Y. Okay. Double checking. Yep, that looks good. Let's give this a shot. Okay, and as you can see, we have the mouse coordinates. They seem to be just anywhere on the document. So if we go off here, they're not working. Just to check, we can see that X is on the left, Y is at the top, and yeah. Okay, very good. So now, oops. Yeah, that's not too bad. The next stage is to look at actually triggering some events with these. Okay, so just one note, well, two notes. Okay, note number one. If I move the mouse around, it would make sense to detect a mouse movement inside the canvas. There's a problem. There's only so far the mouse can move. But for a 3D situation, we want to get heaps of movement, and we probably don't want to see the mouse either. If you've worked with Unity, you know that you can export to WebGL, and you have a situation where if you click on the screen, it sort of grabs your mouse and makes your mouse invisible. But then when you change focus, you get your mouse back. Best of both worlds. So instead of using jQuery to handle the mouse event, I'm going to look at another way to handle it, which will make that a little bit easier. But then the other thing is that, what was I going to say? This will be pretty good. It won't be perfect, and it won't look super good until we have multiple meshes and everything working on the screen. So this is just like, it's a bit rough at this stage, but that's fine. So I'll just close this down, and I'll go to the scene. Sorry, the app. Wait, what am I thinking? No, the scene, definitely the scene. Now I'm going to give the scene a bunch of functions which will let it modify the player. First of all, I want to spin the player. So first of all, dx is the horizontal change. I'll use that to modify the rotation around the z-axis. Again, taking it under mod 360. And then we'll have the rotation around the y-axis, which will be the horizontal, basically looking up and down. Okay, so this is essentially clamping it between 89 and negative 89, which is pretty close to straight up and straight down. It'll be somewhere between there. Again, with these, as I always say, with these looking systems, you might want to play around with it, change a plus to a minus C, which feels more natural. But yeah, this is just what I'm going with for this demo. Then the next function I want to add is moving the player around. Now, the player can be moved around according to the camera's forwards, up, and right vectors. So I'm just going to use forwards and right movement. Now the reason I'm using these vec3 functions is I tried directly adding a bunch of vec3s and computer said no, computer complained. So just using that. So what I want to do is I want to modify the player's position, and I'll take in the player's position. I'll take the forwards vector, scale it according to the forwards amount, and add that onto the player position, save that back as a new player position. And the right movement will be very similar. We'll take the right vector, scale it by the right amount, add that onto the position, save that all back onto the position. Repetition is good. Okay, good. So let's go back to the app, because now the scene knows how to modify the player. The app needs to pass messages to the scene to tell it to do that. Now this approach is just one of many. It is slightly dodgy, but I'm going to do it anyway, because we can always come back and fix it later. Okay, so what I'm going to do is I'm just going to keep track of how far forwards and right we want the camera to move, and then we will determine that in the key press handlers. So here I've got, what is it? This handle key press. We can do this. Okay, so I'll paste this in. It's annoying. Okay, so we've got the event code, and then we want to check the event code. So we'll have the WASD codes here, and according to those, we will set either the forwards or right amount. Now what's dodgy about these is if I hit two keys at the same time, one will overwrite the other. But it's just something I have to put up with, because this handle key press will literally just handle the key down event. There isn't really a way to handle just pressing down a key and holding it. It doesn't work that way. The proper way to do this is to set up a dictionary where the keys to the dictionary are these strings here, and then set like a true false value, but I'll just do it this way. Why not? Okay, so if we release a key, then whatever key we released, we want to set the appropriate vector to 0. So if I press forwards and then I release forwards, I want my forwards amount to go to 0. Okay, so we've got that. Okay, so we've got the key press. I then want to set key release. But then I need to just modify this. Key release needs to be, I'm messing this up. This is a key down event, key up event. Then I'm just going to change these. Okay, cool. So let's pretend that's working fine. We'll check it in a second. What I want to do is these functions will be running in the background, and we'll have some state held by these variables. In my run function, I want to use that. So I'll say, okay, tell the scene to move the player by our forwards amount and right amount. And we'll just trust that these variables are being set appropriately by the handlers. Okay, cool. So let's give that a go. Just go. I should probably import that. Yep, good. Good. Just checking I spelled it right. Okay, let's give that a go. Well, that's not good. Okay, let's try initializing those variables. Yeah, maybe they have a weird default value. So I guess the default value for float is not a number, which is a really large number actually. Let's see what happens. Okay, npm start. Yeah, that was probably it. Okay, so there we have it. Now if we go W, that should bring us forwards. S will bring us back. A to the left. D to the right. Okay. Combination. Oh yeah, combinations work. That's fine. Okay, looks pretty good. Now let's bring the mouse into it. So yeah, that sounds fun. Let's go back. And we're just going to take it one step at a time. So I'm going to move away from the jQuery approach for the mouse. What I'm going to do is what's called a pointer lock. So I'll take the canvas and I'll set the click event to request the pointer lock. Yeah, I'm happy with that. So then I'll just give that a go. So I'm just demonstrating what a pointer lock does, basically, and then we'll get into actually using it to move the camera around. Okay, so I'll pop over here, refresh it. Now everything's working fine. If I click on the canvas, now the mouse has been locked. So it's in a situation where it's invisible and it can actually move as far as I want anywhere. That's fine. I just hit escape and I've got the mouse again, click it, mouse is gone, escape, get it back. Okay, very cool. Now let's actually use that. Okay, so we'll add for the mouse move event, we'll go pretty much the same as before. Okay, cool. Just double checking all of that. Yep, so that's fine. Then I'll go down to, yeah, here we are, the mouse move. So this is, what am I thinking? This is not a jQuery event anymore. It's a mouse event. Okay, and similarly we have a bunch of these other things here. So instead of screen X, we have client X and client Y. But that's not super important. Let's go, okay, tell the scene to spin the player by this is called a movement X. Is basically the delta of how far it's moved since the last time. I'm just going to put 0 for the Y because I just want to show the horizontal movement right now. So I'll just go new terminal. Okay, so refresh that. Now see that, yeah, the mouse is moving right now, but we can also click and it's just a lot cleaner. So again, this is one of those cases where you might want to add a multiplier. As a matter of fact, let's do that. So we'll just go movement divide by 5, I think would be a nice amount. So there we have it, a lot smoother. Yeah, it's looking nice. Okay. And then, again, I'll just 0 that out for now because I just want to keep it nice and simple. I'll go event. Set that. Okay, so now we can go, oops, come on. There we go. Okay. Up and down. This feels a little inverted, but every time I change it, it then feels more unnatural. So I don't know, maybe it's just weird. But yeah, and then, okay, fair enough. We can put all of it together. And it's a little hard to get my bearing because I just have one triangle to look at, but technically this will give me full three-dimensional motion. Okay, so we can go ahead, load that. It might take a bit of... Oh, there we go. Okay, so we can go left, right, up, down. Yeah, feels a little strange, but there we have it. And we can also move around. Yeah, so we can strafe around the triangle. That's nice. That's interesting. Yeah. Anyway, so there we have it. That's a little investigation into getting movement events working. And yeah, a little rushed. But like I was saying, in the next video, we'll look at getting a whole bunch of these triangles on the screen with their own transforms. So yeah, I hope you had fun, and I'll see you again soon. Bye.